In the name of Almighty God, hello, I'm Mahsa Hassan Kashi, and today I want to talk about asphalt reinforcement. Firstly, we went through the assembly module. I have set a bottom for loading the pressure. To have a clear vision, you can select the transparent bottom on the top ribbon. The hidden layers can be seen ambiguously or clearly based on the enable transparent percentage. The controversial layer is the geocell, which is a steel alloy shell beneath the layers in order to fortify the structure. Actually, the geocell is the reason to avoid the decoy of the whole construction. The first step is to define geometry in the part module. The second step is to define the materials for each individual parts with every single of their own properties, such as density, elasticity, and more coulomb plasticity. Actually, density talks about the mass of geometry which has been contained in a specific volume in 3 dimensions, and it is measured by the unit of kilogram. Elasticity explains the ability to return to its original shape after the pressure force finished or removed, while plasticity is the hardness of material and how much material can tolerate pressure without breaking. The key difference is the elastic deformation is reversible and plasticity is irreversible, which is depend on friction angle and dilation angle. The third part is section assignment, which is crucial for binding material to the geometry. And as you can see, for each material there is a section in section manager. We can observe the geocell has section 2 with its own material, which is shell and homogeneous. Then we go for the step definition after section assignment. Now it's the time we go for the step definition, which I have selected dynamic. This is the mesh, and this assembly you can see the through the after transparency inside the box. And then we go for a step definition, which I have selected dynamic explicitity procedure. The incrementation is automatic and NLGOM would be turned on. Then in the field output we can select the desired variable which will be studied in Abaqus simulation based on finite element method during time passes. For example, we can select displacement, stress, strain, or force reaction in different axes, volume thickness, and etc. Now in history field output, we can store results for the specific set or geometry. Here we can select z-axis due to the pressure applied in this direction. Now we can select the stress, and you can see that the pressure bottom here is applied on z-axis, as you can see here. Now there is a gap between bottom and the surface, as you see here, and we want to close this gap by going through the assembly module. We go to the assembly module because bottom is not totally relies on the surface. Therefore, we go through assembly and choose the translate tool and select proper point and drag it into this exact top of the surface. Now it's completely rely on the Next, we go to interaction. In the interaction module, the first constraint is embedded region, which is always used in the jaw cell because it is required to be fit and embed through the rest of foundation. And the friction and etc. we leave them as default setting. The next constraint is tie, which make jaw cell tied to the top surface. In interaction property section, we select tangential and normal behavior. The final section in interaction is general contact, which is surface to surface type for all parts. Now we go through in load module. In load module, the pressure is distributed uniformly on the top surface with a specific amplitude. The amplitude and magnitude is specified here. Now in module in boundary condition, in load module in boundary condition section, we should fix the bottom of the soil box in order to keep it unmovable by using encastering the axis. Another boundary condition is as BC2, the whole system has permission to move except the specific direction. Now we go through the mesh. The mesh has been selected quadratic in a square shape and the approximate global size of seeds and quantity has indirect relation. Larger size causes less number. Now we go through visualization after performing the job. Eventually, we have the visualization at the end and we can see the outcome for stress and strain plot. Now we can select the specific variable, for example, stress. During the time, we can see for a specific node of geometry.